Hey guys, sorry for the delay. Today we are talking about the light meter that I built. So here is the code. It's a little big right now, but I did shrink it a little bit. But anyway, let's get started. We use two sensors in the light meter. The TCS34725 is the color sensor, and the TSL2591 is the light sensor. Both of them from Adafruit. This light sensor has a really good sensitive. I can say it's better than most light meters in the market, at least in the specs. Okay. The color sensor, I have no idea if it is perfect or not, but it is really accurate. I will show you later a comparison with another color meter. Okay. For display, we use the monochrome. I use the 0.96 version. Okay, let's go to the code. This is the last version that I built. I did some changes. I removed the photo mode, the mode for stills, because I was not using it. The size of the code, just for you to get know, it's 83% used and 78% memory used. Before that, so here is with photo mode. I'm using 99% of the total available space memory for the code, and 87% for the dynamic memory. And this is a problem. There were some errors and a low speed performance. Okay. I think in the future I will make only the photo mode. So if I want to use photo mode, I will just upload the code, and if I want to use the cinema mode, I will upload this one. Okay, let's jump in. First of all, we have to include some libraries, and I will not spend a lot of time explaining all these libraries. The only thing that I will explain a little bit, because I don't remember how it works exactly, is that they share the same I2C port. Okay. Here in the site I can see, unlike TSL2561, the other version, you cannot change the I2C address. So keep that in mind. Okay. I had to make a new library for one of the sensor. I choose this one because it was simpler. To like create a virtual I2C address. Okay, keep that in mind. Include SPI, wire, Adafruit GFX. You have to include all these because otherwise we will not access the sensors and the display. Include EEPROM. This is a library for the memory of the Arduino. You can save some settings. Define reset. This is for the display. This is for the display. These are constants for calibration. I took this from the RGB sensor library. Okay, color sensor, auto range. The calculations and some calibrations as well. Here you can see some magic numbers for this device from D4D application notes. D4D, here is the link for D4D, here. So it is what it is. C constant 129. This is a calibration constant for the TSL2591. It's a calibration that I made for this sensor using my camera as a reference. DOM multiplier. Multiplier when using a white translucent DOM covering the sensor. Here is the DOM sum. It's for the color sensor. More tests required, but the difference in the first test was around 100k, so I didn't use it because it was like not that much. We are removing light when we put something on top of the sensor. Here we create some integer, floats, strings and booleans. The middle button is the metering button. The top one is the plus, the increment button. The bottom one is the increment minus increment. Okay. What is AM? It starts photo mode with F4. Okay, let's start. Array for cine values. Float A is the aperture. 0.7, f 0.7, f 0.8, f 0.9, f 2.8, f4, and so on. You can see that these lists go on. AM means the number that we put here inside this array. So a 15 value will give us f4. Okay. TCA shutter angle selector in T angle here. TCA goes here. S address number 1. S and T address will be for the memory, for the EEPROM memory. I have a little buzzer inside the light meter that beeps when I get a new exposure. Okay, basically that's it. Don't worry about these things right now, but float lux is the value that we are gonna get from the light sensor. Okay, CT is the color temperature from the color sensor. ND is values for the neutral density filter. I'll show you later how it works. Float TV, I remove it, but if you want, you can uncomment this. I think the code is down there if you want to use it. Boolean button 1, Boolean button 2. Okay, R metering button state. It's either 1 or 0, of course, because it's a button. ISO mode is a Boolean as well. When it is 0, it means that you are not changing the ISO. When it is 1, you can change the ISO. Save, it's for saving to the EEPROM. Okay. Freeze, it freezes any action that you use. When you freeze, you can't change the shutter speed anymore for you not accidentally press it. Okay. Angle mode is for working with shutter angle, not shutter speed. Need high. High gain is applied at 428 times gain, and display high in the display. If you are in a low light situation, it's gonna apply this gain. Okay. Overflow, sensor got saturated and display overflow. ND mode, changing the ND. So here is the arrays. S is the ISO array. If you have another values in your camera, you can put here. And if you wanna go higher than this, you can. Okay. Float A is the aperture, we talk about it. T cine is the frames per second. T angle, the shutter angle. Okay. ND, this is 0.3, okay. 0.6, 0.9, 1.2. So a 0.3 ND will remove one stop. EEPROM for saving memory, it's gonna save the ISO and the shutter speed. When you turn off your device and turn on again, it's gonna keep the shutter speed and the ISO. Color sensor get color temperature. This is the function to get a new color value. CT is the color temperature. It's all we are looking for. Void setup. This is the buttons, the display. This is the animation. Lux get lux. So when you turn on your device, you will get a new exposure. So when I turn on, we have exposure. Okay, f28, 3200 kelvins. Void loop. The first thing you do, you can see, is read all. If button plus and M are both pressed, save EEPROM data and freeze the settings. Let's check it out. If we press it, save equals 1, freeze equals 1. Save it and freeze it. If we press the up and down, we can change anything. So it is freeze it. If save equals 1, if TCM equals 2, T 0, 1, 2. If it is in 24 FPS or 1/48, it's gonna go to the angle mode. Okay, now we can change angles. It saves to the EEPROM address. Mode window is a function to animate the text saying freezes, save it, and these kind of things. Angle mode equals 1. I can change the values of angle mode. This code is only for adding numbers, okay? Let's try this out. So if you are in angle mode, top button, we are changing the angle value, okay? And this code only returns to the first value after you press it. Minus will do the opposite thing. and give you the same result. If freeze equals 0, read button plus and increment shutter value. So you can see 150, 160, 196, 100, 120, 192, 200, and so on, okay? Same thing, minus, same thing, up, down. And minus are pressed. We go to ISO mode, okay? Here's the ISO mode. Here we can change the ISO. You can see that I'm changing the ISO. ISO mode equals 1, debug, save equals 0, so when we are saved, then we can change the settings. When we save the settings, I can change the values of the shutter speed. If I save it and freeze it, I can't change it anymore. But if I enter in the ISO setting, I can change the ISO, and when I get back and press it again, select it and unfreeze it, I can change again the shutter speed, okay? And this is the code for everything of this. And by the way, I'm leaving the angle mode as well when I choose my ISO, unfortunately. Now, if I'm in ISO mode and I press the middle button, ND mode equals 1. And now if I press up, I can change the ND value, okay? You can see I press the middle button. While holding it, I can increment and decrease the value of the ND. If you are not pressing the middle button, you can change the ISO, obviously, as we showed before. Refresh button delay. If the middle button is pressed, get a new lux value and color temperature value. Lux get lux, this is a function. RGB sensor, it's another function to get color and to get light. And, of course, beep. Overflow, I will explain later. But if overflow equals 1, delay a little bit and get a new exposure. Float get lux is the main function to get the new exposure. This is from the examples in the libraries. This I did some changes, of course. When need high is applied, I'm choosing to set the gain of the sensor to be this one, okay? Else, if need high equals low, equals 0, use one-time gain. When event light equals 0, when sensor gets saturated, normally in transitions between gain, in these situations, I put a value in the lux to properly change them from this gain to this gain. Display overflow. If overflow equals 1, it's gonna get a new exposure. When we get the lux value, we have to multiply for the dumb multiplier. Remember up there? If lux is less than 40, need high equals 1. And we need to apply more gain to be more accurate, okay? And this is the offset corrected here. If need high equals 1, we have to apply this multiplication to get accurate again. If lux is greater than 200, need high equals to 0. Why this is not 40, right? Because otherwise it will always be changing from these ones, and 200 is actually a low light situation, so we can expend a little more time in need high if we really need, okay? Return lux, so I finally get the lux value up there. Here is the function for delaying the buttons. For debug again, void refresh. This function gives a new calculation based on the last illuminance value and refreshes the display. This is the math. This is the math and the display of this math, okay? Cine mode, T final, shutter speed or shutter angle. This is the real value in time for the calculation. String EV is the f-stop. I'm not sure why I chose EV, but I did. EV plus, it's thirds of stops, okay? It's the plus 1/3 of a stop plus 2/3 of a stop. If angle mode equals 1, this is the formula. So if you are in angle mode, we have to use this formula to get the final time, the real time, okay? Else, if we're in shutter speed mode, we have to do this calculation. if ND is greater than 0, so if it is activated, ISO ND, so we change the S, okay? Else ISO ND is the same as the ISO. And here is the main formula for the aperture. This formula is on Wikipedia. Here is a lot of bullshit, okay? If n is equal or greater than 2.8 but lesser than 3.2, f equals 2.8 and EV plus equals 2. What EV plus means? EV plus 2, 0, 1. Probably if EV plus equals 2, it means it's only f2.8, okay? EV plus equals 0 is plus 1/3 and 1 2/3, okay? Basically that's it for all this fucking huge thing. Yeah, if you know how to do this better, please tell me. So this is for the display, okay? I'm not gonna bother that much here. If you want me to explain this better, please ask me, okay? Because this is really boring. Set cursor to x0, y52, display print, the value, right angle, basically all this bullshit, okay? But this is important, of course. If need high equals 1, display print high, and create a square around it. Okay, basically that's it. Thank you for watching. Let's test the white balance. Let's get exposure. 4900 in here. 4883. It's basically the same. Come on. Let's try in a different light. Okay, we are in incandescent light. 2500. 27, 58. It's okay. Okay, same light, but now with the correct Kelvin, with the correct white balance. As we can see, it's pretty damn close, right? Pretty damn close. This one is with a LED lamp, and as you can see, they got really close again. 3000. And this one, pretty damn good, right? Thank you for watching.